Hey everyone, welcome back to our Space and Science channel. Today we've got something super exciting to talk about, a long-awaited event captured by NASA's James Webb Space Telescope. We've got our first direct look at a phenomenon in the Serpens Nebula. In this amazing image, we see a bunch of protostellar outflows in the northern part of this young star-forming region, all thanks to gas jets colliding with surrounding gas and dust. Typically, these outflows go in all sorts of directions, but here, they're all aligned in the same direction and angle. This discovery was made possible by Webb's incredible spatial resolution and sensitivity, giving us crucial insights into how stars are born. As Klaus Pontoppidan from NASA's Jet Propulsion Laboratory said, astronomers have long assumed that stars forming from collapsing clouds would tend to spin in the same direction, but we've never seen it this clearly before. So, how does the alignment of these star jets relate to a star's rotation? When a cloud of interstellar gas collapses to form a star, it starts spinning faster. The only way for gas to keep moving inward is for some of this spin, or angular momentum, to be removed. A disk of material forms around the young star, and magnetic fields in the inner disk fling some material outward in twin jets perpendicular to the disk. In Webb's image, these jets show up as bright, clumpy streaks, thanks to shock waves created by the jets slamming into surrounding gas and dust. The red color in these streaks indicates the presence of molecular hydrogen and carbon monoxide. Joel Green from the Space Telescope Science Institute said, "This area of the Serpens Nebula, Serpens North, can only be seen clearly with Webb. We're now able to capture these extremely young stars and their outflows, some of which used to appear as just blobs or were completely invisible in optical wavelengths because of the thick dust surrounding them." The Serpens Nebula is located about 1,300 light-years from Earth and is cosmically young, only 1 or 2 million years old. It also hosts a dense cluster of newly forming stars, some of which will eventually grow to the mass of our Sun. Webb is a young star object-finding machine, says Green. In this area, we're picking up signposts for each young star, even down to the lowest mass stars. Looking ahead, the team will use Webb's NIR spec to study the chemical makeup of the cloud. This research will help determine how volatile chemicals survive in star and planet formation. Pontoppidan said, "Looking at the abundance of these critical compounds in protostars right before they form protoplanetary disks helps us understand how unique the conditions were when our solar system formed." For more updates and info on this topic, don't forget to subscribe to our channel. See you in the next video.